Hello, this is Mr. Stansbury. I'm going to take you through the notes on inverse variation. At the end of this, you should be able to say, I can show that two variables can be inversely proportional, and I can find a formula connecting the variables. Okay, so two variables are inversely proportional, or very inversely, if one variable is multiplied by a constant, the other variable is divided by that same constant, which is, I know, kind of confusing. Here's what this means. If y is inversely proportional to x, then y is directly proportional to 1 over x. So what we get, so we'll say y is directly proportional to 1 over x, or inversely proportional to x. So what this means is we get y equals k times, instead of k times x, it's y equals k times 1 over x. So we can write, if we multiply k times 1 over x, that gives us y equals k over x, which is the inverse proportionality formula here that we use. But if you think about this, if we multiply both sides by x, multiply by x here, multiply by x here, it says xy equals k, which is a little bit easier formula to use, and it's also an easier formula to remember. So all we're going to do is we know we're just going to multiply the two constants together and to come up with our k. Okay, actually not the constants, but the two variables. We'll multiply the two variables together to get our constant, and then we can, once we have one of the variables, we can, with our constant that we figured out, we can figure out the other variable. Okay, so let's take a look at some examples here. So suppose y is inversely proportional to x and y equals 20 when x equals 6. Find k. So if we use our nice easy formula, we know that we have x times y equals k, and we are actually using x and y here, so just whatever the two variables are, we'll just multiply those together to find out what our proportionality constant is, and then that k will stay the same no matter what we plug in for x and y. Okay, so in this case here, we got y is 20, x is 6, and that will give us what our k is. So 6 times 20 is 120, and that's what our k is. So now our formula that we can use for all of these is going to be x times y is going to always equal 120. Okay, so we can use that formula over here, but before we do that, let's take a quick little comedy break.
The ultimate, though, in looking like an idiot is when you walk into a spider web, right? Because nobody else sees that spider web. They just see you walking off in the distance, suddenly flipping out for no reason whatsoever. You know, you're just walking along, everything's fine, all of a sudden, no! No! Did you see that guy? Yeah, he just snapped. He was walking along, he just went nuts near that tree. Look, he's still doing it.
All right. So let's use our formula. We got x times, let's change it back to blue here. So we got x times y equals, it's always going to equal 120 now for the rest of this problem here. So find y when x is 18. So we just do 18 times y equals 120. So to get y by itself, we simply divide both sides by 18, and we will get that y equals 120 divided by 18, and we get 6.67, we'll call it. Okay, and then we can do the same thing here. Find x when y is 7. So we got x times y equals 120. Our y is 7. We'll figure out what our x is. Divide both sides by 7. And x is going to equal whatever 120 divided by 7 is. Okay, and that gives us 17.1, we'll call it. 17.1. Okay, so as you can see here, as one number goes up, the other one is going to go down. So it's inversely proportional. So the bigger one of the numbers is, in order to make up for that, since you're multiplying together, you always get 120 on this. So this number from the original one. Let's see, y was the big one. So x got big, so y had to get smaller to make up for it. On this one here, y got smaller, so x had to get bigger to make up for it. Okay? All right, that's all we have for inverse variation. If you have any further questions, please feel free to ask in class. Thanks.